Today we're taking a look at doing a linear regression on the NumWorks calculator. Pretty easy. On the home screen here we have a regression option, so in the bottom middle for me. So go down to that, hit the execute button. Brings you straight to the XY table. So I'm just going to make something up here. So 1, 2, 3, 4, and I use the arrow key to go over it. I'm just going to type in 5, 6, 7, and I'll just throw in like a 12 just to throw things off here. Okay, so take a second, type those in. Pause the video, and then start it up in just a second. Now that we have the x and y values in there, remember you need to have the same number of x's as you do y's. If they are out of order or they're mismatched there, you'll get an error. So for this thing, if I want to get to graph here, I have a couple different options. If I go up to here, go over to graph and I hit enter, I end up with these. I might have to change the window, but for right now it looks pretty good, and I can see that it looks like it's fairly linear. It looks like at that top, the x value, or the value that had a 412, been a little bit lower, been a little bit better here. But I can see right down here at the bottom that it's giving me the correlation value. Remember that correlation value is between 1 and -1 inclusively. If it's at 1 or -1, it fits it perfectly. The coordinates fit perfectly to that line. But the farther or the closer they are to 0 from the left and right hand sides, the less the data is predicted by your regression. So it means those points are farther away from the linear regression. So one of the things that we want to do with this is, one of them is to find the equation of this line. Right? So one of the things that we can do here is if we go under the toolbox button, and I take a look here, I can see that I have option number 1 is linear, so it's mx plus b. So if I hit enter on that, I can see that I end up with this line drawn in here, which is actually pretty nice. It gives us some information down here at the bottom. But really what I want to do with this thing is back under the toolbox here. I can see that I have the rounded version of the equation. So I have 2.2 as my slope, and my y-intercept is 2. So that's great. So if I have the equation, I can do that. I have my r value, so it's at 0.91. So for most things, that's a pretty good correlation. Pretty strong relationship. Is a strong linear relationship between the input and output values. R squared is variance. You'll deal with that in stats, but for right now, we're not really looking at that. But here, we're trying to predict y values given an x value. It's a very common thing here. So if I hit enter on that, I can type in whatever I want. So say I want to type in 5 for my x value, go down to confirm, hit enter, and I get the corresponding y value out of 13. Now what's nice about this is if there's a follow-up question that says, okay, now when x is going to be 11, what's it going to be? Or when x is 4.5, what's it going to be? You can just type in 4.5, hit enter, it gives you the corresponding y value. And you can keep doing that for as many values as you need. But say that you wanted to find the x value when the y value was given to you, go back under the toolbox, scroll down, find x given the predicted y. So maybe I want to put in 7. Okay, go down to confirm. It's going to be give my input value for my x value, and so that's when y is 7, x is going to be that value there. So this does everything we need. Okay, so it's a pretty good setup here. You can use the rounded version of the equation, but this is using a non-rounded version, or should be. So I'm guessing it's something slightly off from there, but it's possible that could be exact for this particular situation. Okay? And that's all there is to it.